In this session, I am going to discuss about the topic motion. In this chapter, I am going to discuss about the meaning of motion, types of motion, rest, uniform motion, non-uniform motion, distance, displacement, speed, velocity, acceleration, equations of motion and circular motion. So these things I am going to discuss. Let us begin the topic with the meaning of motion. As all of us know that on the road vehicles are moving. On the grazing field animals are moving from one place to other place. We say that they are in motion. What is the definition of motion? A body is said to be in motion if its position changes with the surrounding. Say for example, a car moving on a road, a teacher moving in the classroom with respect to surrounding. Fine. And we have come across several types of motion. We have seen linear motion. That linear motion is also known as rectilinear motion or straight line motion. And we also have seen the rotational motion of a fan, the rotational motion of a top. We have come across the circular motion of the moon. Fine. So what is this straight line motion? If any object that moves along the straight path, the body is said to have straight line motion or the rectilinear motion. For example, the motion of a bullet along a straight line, the motion of an arrow, or the motion of a javelin, the motion of a train along a straight track. These are few examples of straight line motion. They are also known as one-dimensional motion. And we have come across rotational motion. The motion of fan about its axis is the rotational motion. The motion of the top about its axis is the rotational motion. The motion of earth about its axis is the rotational motion. And because of its rotational motion, we come across the days and nights. Right? We also know about the circular motion of the moon, the circular motion of an electron around the nucleus, the circular motion of a satellite around the planet. Yes, what is that circular motion? Any object that moves in the circular path is said to have circular motion. As I have given you the examples, the motion of moon around the earth is the circular motion. The motion of an artificial satellite around the earth, maybe a polar satellite or the geostationary satellite, the motion of such a satellite around the earth is said to have the circular motion. Fine. And the rotational motion I have given you. The motion of fan about its axis is an example of rotational motion. Fine. Then, what is rest? We say that the board is at rest, or the tube light which is fixed on the wall is at rest, or a portrait that is hanging on a wall is at rest. What is rest? A body is said to be at rest if it does not change its position with the surrounding. For example, a stool or a chair kept in a room, it does not change its position with respect to the surrounding of the room. Therefore, the chair or the stool or the almirah is said to be at rest. Fine. Then, what is uniform motion and what is non-uniform motion? If a body covers equal distances in equal time, the body is said to have uniform motion. Say for example, a car. A car covers 0 kilometer in 0 second, 2 kilometers in 10 seconds, 4 kilometers in 20 seconds, 6 kilometers in 40 seconds, 10, 20, 30 seconds. The distance is in meter or kilometer. Say for example, kilometer or it may be meter. 0 kilometer in 0 second. It has covered 2 kilometers in 10 seconds, 4 kilometers in 20 seconds, 6 kilometers in 30 seconds. Or in other words, an object has covered in terms of meter, 0 meter, 0 second, 5 meters, 2 seconds, 10 meters, 4 seconds, 15 meters, 6 seconds. Such a body is said to have uniform motion. If any body covers equal distances in equal time, the body is said to have uniform motion. For example, a troop, soldier or NCC, they cover equal distances in equal time. The body is said to have uniform motion. Well, what is non-uniform motion? If any body covers unequal distances in equal time or equal distances in unequal time, the body is said to have non-uniform motion. Fine. Let us look into the example of non-uniform motion. X, T. Here, time 0 second, 2 seconds, 4 seconds, 6 seconds, 8 seconds, 10 seconds. Equal time. But distance covered by the body is not equal. Say here it is 0, then 4, here it is 10, here it is 15, here it is 20, and here it is 30 meters. In 0 seconds, 0 meter. After 2 seconds, it has covered 4 meters. After 4 seconds, it has covered 10 meters. After 6 seconds, it has covered 15 meters, and so on. So, unequal distances are covered in equal time, or equal distances are covered in unequal time. Say for example, X, T. X is in meter. Here also X is in meter. T is in second. Equal distances in unequal time. 0, 4 meters, 8 meter, 12 meter, 16 meter, 20 meter. Time, unequal time, 0, then 2 seconds, then 5 seconds, then 9 seconds, then 15 seconds, then 19 seconds. A body covered equal distances in unequal time. Such a body is said to have non-uniform motion. What is the nature of graph for uniform motion and for non-uniform motion? The nature of graph for uniform motion, that is the graph of x versus t. T is in seconds, x is in meter. Then if it is a straight line, it indicates that equal distances are covered in equal time, and this is the graph of uniform motion. For non-uniform motion, for such situation, the graph would be like this. Curve. That curve indicates that the non-uniform motion of the object. If the object is at rest, what is the nature of xt graph? Xt graph, position time graph, distance time graph. This is for uniform motion. This is for non-uniform motion. And this is for rest. When the body is at rest. Fine. Then let us move on to the next topic. What is distance and what is displacement? Fine. Yes, distance is the path length travelled by a body, path length covered by a body is known as distance. What is displacement? The shortest distance between initial position and the final position is known as displacement. Fine. Look at distance and displacement. Here is the distance and here is displacement. Let us learn the differences between distance and displacement. It is the path length covered by a body, or it is the length of a path from the initial position to final position. It is the path length covered by a body from initial position to final position is known as distance. What is displacement? It is the shortest distance between initial position and final position. For example, if you consider a circle, the distance covered by an insect in completing one circle is 2 pi r. 2 pi r is a distance. What is displacement? Displacement is 0. Distance is 2 pi r. From here to here is r. The task is very simple here. There is an insect. It completes one circle, one round. What is its distance? The circumference of the circle is equal to the distance covered by the insect. The circumference of the circle is 2 pi r. So distance is 2 pi r. Displacement, that is the shortest distance between initial point and the final point. initial point and the final point, since both are same, therefore displacement is 0. Fine. Distance is a scalar quantity which has only magnitude. Distance 500 kilometer, 300 kilometer, 20 meter. These are known as magnitudes. Displacement is a vector quantity which has both direction and magnitude. Direction means towards south, towards north, towards east, towards west, vertically upward, vertically downward, northeast, southwest, and so on. These are known as directions. Okay, so this displacement has the nature vector. It has both magnitude and direction. Say for example, there is a road to the top of the mountain. Here is the mountain. This road, this is the bottom point. This is the top point of the mountain. This is the road it takes to the top of the mountain where there is a temple. From here to here, 25 kilometers. The 25 kilometers is the distance. And what is displacement? The shortest path. This shortest path, that straight line, that gives displacement. Distance may be equal to displacement or always more than displacement. Only two possibilities are there. Distance may be equal to displacement or may be greater than displacement. But distance never be less than displacement. Fine. If it is a straight line motion, displacement and distance will be equal. If it is a curvilinear motion, distance will be more than the displacement. Fine. Okay. Now let us try to differentiate. Distance is measured in meter and displacement is also measured in meter. Distance cannot be 0. It cannot be 0. Distance cannot be 0. But displacement can be 0. Here, just like in completing one round, displacement is 0. But distance is always positive. It's always positive. Distance is always positive. But displacement can be positive, can be negative. Positive or negative, depending upon the direction. Say for example, if you are taking onward journey, displacement is positive. Return journey, displacement is negative. Say for example, a person jogging from A to B. A person jogging from A to B. This displacement is positive. At B, he returns and goes to the point C. So this B to C, this displacement is negative. So if you consider the onward journey displacement is positive, the return journey displacement will be negative. Okay. So here, suppose A to B is 100 meter and B to C is 50 meters. What is the distance and what is the displacement? Distance from A to B, B to C. A to B and then B to C. Distance is 150 meter. From A to B, B to C. What is the displacement? From A to B, B to C. displacement is 50 meter. That is the shortest distance between initial point and the final point, 50 meters displacement. So in this case, displacement is less than distance. Okay, if you consider A and B 2 points, 100 meter, then what is the distance and displacement between A and B? Distance is 100 meters, displacement is also 100 meters. Fine. So, what is a scalar quantity? A physical quantity which has only magnitude is known as scalar quantity. For example, distance, speed, length, time, mass. These are few examples of scalar quantities. They have only magnitude. What's a vector quantity? A physical quantity which has both magnitude and direction. For example, velocity, it has both magnitude and direction. Speed with the direction is called velocity. So velocity is a vector quantity. Displacement is a vector quantity. Acceleration is a vector quantity. Force is a vector quantity. Weight is a vector quantity. Power is a scalar quantity. Work is a scalar quantity. Energy is a scalar quantity. Magnetic field, a vector quantity which has direction. Electric field, a vector quantity. So, some physical quantities are scalar, some physical quantities are vector. Those quantities which have only magnitude are known as scalar. Those quantities which have both magnitude and direction are known as vector quantities. Fine. I will stop here. We will continue our class in the next period.